Welcome to Smart School Digital Learning. Children, today I will introduce you how to integrate a given function. At this stage, it is expected that the children know the basic formulas of differentiation. Basically, integration is the reverse process of differentiation. Sometimes initially, without giving meaning to this integration, we use the crude word integration, but basically it is antiderivatives. We start with the first formula here. D upon dx of x raised to power n plus 1 divided by n plus 1. If we differentiate, so we have 1 upon n plus 1 and we differentiate this power x raised to power n plus 1, which is n plus 1 into x raised to power n plus 1 minus 1. This n plus 1 gets cancelled with this and we are left with x raised to power n. That means if you differentiate this function x raised to power n plus 1 over n plus 1, we get x raised to power n. So, we can write down antiderivative of this x raised to power n d of x. This is a symbol for integration elongated s. Okay, if we differentiate this function, we get this, but the reverse process is, okay, if we integrate it or find the antiderivative of this, this is equal to x raised to power n plus 1 divided by n plus 1 plus constant c. Now, this formula is valid when n is not equal to minus 1. Then comes d upon dx of ax plus b raised to power n plus 1 divided by n plus 1. Now, the difference between this is x is being replaced by ax plus b divided by 1 by a. If we differentiate it, we get 1 upon n plus 1, this is a constant term both in the denominator, and differentiate this part numerator. So, this is n plus 1 into ax plus b raised to power n plus 1 minus 1 and then derivative without power, that is a. This n plus 1 gets cancelled with this, a gets cancelled with this, and we are left with ax plus b raised to power n. This 1 and 1 gets cancelled. Proceeding in the same way here, so integral of ax plus b raised to power n, integral of ax plus b raised to power n d of x is equal to ax plus b raised to power n plus 1 divided by n plus 1 divided by coefficient of x as a plus constant c. If we observe that this quantity was obtained by differentiating this ax plus b raised to power n plus 1 upon n plus 1 into 1 by a. So, if it is a linear function, that means ax plus b raised to power n d of x equals to ax plus b raised to power n plus 1. the stress is to be laid that this function a x plus b, it must be a linear function, then and there we can apply this formula. For instance, instead of x, we have x square here, so we cannot apply this formula. I will again repeat it, that if it is a linear function a x plus b, power of x is 1, then and there we can apply this result. Then we have d upon dx of sine of x. It's a very popular formula, derivatives. Derivative of sine x is cos of x. So, obviously using the above concept, so integral of cos of x d of x is sine of x plus constant c. Now, if on the right hand side we differentiate sine x plus c, so derivative of sine x is cos x and derivative of the constant c is 0. Then we have d upon dx of minus cos x is sine of x. Derivative of basically cos x is minus sine x. This minus and minus will get cancelled, sine x. So, integral of sine of x d of x to minus cos of x plus c. Then next is d upon dx of tan of x. Tan of x is secant square x, and therefore integral of secant square x d of x is tan of x plus constant c. The next is d upon dx of minus cot x. Derivative of cot x is minus cosec square x. That minus and minus sign will get cancelled. So, this is plus cosec square x. Therefore, integral of cosec square x is minus cot of x plus constant c. Then derivative of secant of x is secant x into tan of x. Therefore, integral of secant of x to tan of x d of x, it must be accompanied by dx here also, equal to secant of x plus c. Then we have d upon dx of minus cosec of x. This is cosec x into cot x. Therefore, integral of cosec of x into cot of x d of x is minus cosec of x plus constant c. These are the basic formulas using these trigonometric functions. Thereafter, we have integral of cos of ax d of x. Make the difference here, that here it is cos x, here is cos of ax. The same formula will follow sine of ax plus constant c. but divided by coefficient of cos A x here. Then integral of sin of x d of x is minus 1 by a cos of a x. If you compare these formulas with these first two formulas, this one and this one, we observe here integral of cos x is sin x, but here instead of x here it is being replaced by a x. So, the same formula will come sin a x, but divided by coefficient of x. Then integral of secant square a x d of x is 1 by a tan of a x. Then integral of cosec square a x d of x is 1 by a cot of a x plus c with minus sign here. Then integral of secant x a x tan of a x d of x is secant of a x divided by coefficient of a plus c. And lastly, we have cosec of a x cot of a x d of x is minus 1 by a cosec of a x plus c. Now, these formulas met for children, those who are starting this integration for the first time in class 12. And after comparing these results, I may repeat that if it is cos x, integral of this cos x is sin x, but if it is cos of a x, instead of x we have a x here, the formula becomes sin a x divided by coefficient of x. Well, these will be proved later on with the help of either differentiating the right hand sides and then obtaining this result, or by a method which we shall proceed in the subsequent chapter as substitution method. By that method also we shall be able to prove these results. Proceeding further, we have d upon dx of sin inverse x as 1 upon under root 1 minus x square, and d upon dx of minus cos inverse x is again 1 upon under root 1 minus x square. So, if we observe the right hand side here, integral of this will be sin inverse x, also integral of this will be minus cos inverse x. So, we have the formula from here, okay, 1 upon 1 minus x square under the root d of x equal to sin inverse x plus c, or cos inverse x with minus sign plus c. Then we have d upon dx of tan inverse x, which is 1 upon 1 plus x square, and d upon dx of minus cot inverse x is also 1 over 1 plus x square. So, therefore, combining this result, we have integral of 1 upon 1 plus x square d of x equal to tan inverse x plus c or minus cot inverse x plus c. Then derivative of secant inverse x is equal to 1 upon x under root of x square minus 1 and d upon dx of minus cosec inverse x is minus 1 over plus x under root x square minus 1. So, making use of this, we have integral of 1 upon x under root of x square minus 1 d of x equal to secant inverse x plus c or minus cosec inverse x plus c. So, normally we use the formulas in this case as this formula is normally used unless it is required somewhere. Integral of 1 upon 1 minus x square under root is sin inverse x plus c. Likewise, this formula is being used normally as 1 over 1 plus x square dx as tan inverse, and same case in this case of integral of x under root x square minus 1. Again, I will lay stress that these formulas can be established otherwise by substitution in the subsequent chapters. Then next is d upon dx of log of x. So, this is 1 by x. So, therefore, integral of 1 by x d of x equal to log of x mod. This is plus c. We take mod here in this case only because log is defined for a positive number. If it is integral of d upon dx of log of ax plus b is 1 by ax plus b into a. So, integral of, in this case, a upon ax plus b d of x is equal to a to log of ax plus b divided by a plus c. Otherwise, if we look towards log of ax plus b, its derivative is 1 upon ax plus b multiplied by a. d upon dx of, otherwise, log of 1 by a ax plus b is ax 1 upon a to 1 over ax plus b into a. This a gets cancelled with this. So, integral of 1 upon ax plus b d of x will be log of ax plus b divided by coefficient of x plus c. Then we have more formulas in this. Okay, d upon dx of e raised to power x is e raised to power x. So, therefore, integral of e raised to power x d of x equal to e raised to power x plus c. If it is d upon dx of e raised to power ax plus b divided by a. So, this will be e raised to power ax plus b, a into integral of e raised to power ax plus b d of x. This will be e raised to power ax plus b divided by coefficient of x plus c, and then d upon dx of a raised to power x divided by log of a. So, this is 1 by log of a into derivative a raised to power x log of a. This gets cancelled. So, therefore, we are left with a raised to power x. So, therefore, integral of a raised to power x d of x to a raised to power x divided by log of a plus c. You can put mod here. बच्चों अभी हमने ये जो formulas of integration discuss किए हैं, these are the basic formulas. In fact, 90% of the questions are solved by using these basic formulas. Before you start doing any problem on integration, it is always expected that these formulas of integration should be on your tips. Once you learn these formulas and practice thoroughly, it will be an easy task for you to tackle any problem in integration. Now, in addition to these fundamental formulas, we have another two very important formulas which are being used in integration. The first formula is integral f dash x upon f of x d of x equals to log of f of x plus constant c. So, we observe here that if f x is in the denominator, then its derivative is in the numerator, and then we have this formula as log of f of x d of x. And secondly, the other formula is integral of f of x whole raised to power n multiplied by its derivative f dash x d of x. So, this is f of x raised to power n plus 1 divided by n plus 1. plus constant c. And if you compare both these formulas, we observe that f dash x is in the numerator here and f x is denominator. For instance, I want to use the first formula, so I can write it as integral 2x upon x square plus 1. It is a very simple problem I am discussing, okay, how to use this first formula. Now, derivative of x square plus 1 is 2x. So, straightway we can use this formula and write that integral of this is a log of x square plus 1 plus constant c. And if you want to check whether your answer is correct or incorrect, you differentiate the right hand side. And when you differentiate the right hand side, you should get this 2x over x square plus 1. And then this is the application of the first formula. Application of the second formula is that if you have x cube minus 1 whole raised to power 6, say, and multiplied by the derivative of x cube minus 1 d of x. Now, here f x stands for x cube minus 1 and its derivative 3x square as its coefficient d of x. The answer to this problem will be x cube minus 1 raised to power 6 plus 1 divided by 6 plus 1 plus constant c. That is, you can write down this as x cube minus 1 raised to power 7 upon 7 plus constant c. Well, we can establish these both formulas in this way. If we take the left hand side of the first formula, this is f dash x divided by f of x and d of x, integral of this. We make the substitution, let f of x stands for say t. So, f dash x into dx into d of t. Otherwise, you can, in normal process of differentiation, you write f x equal to t and derivative f dash x equal to dt upon dx. Here in this case, we write it as f dash x, x with respect to dx and derivative of t as dt. Well, if we replace this expression in the numerator f dash x to dx by d of t upon t. So, we can integrate it as log of t plus c, and now this t replace it by f of x, because t stands for f of x. Likewise, for proving the second result, we take the left hand side of second result. This is f of x whole raised to power n. F dash x complete by this d of x and integral of this. Again we make the substitution, let f of x equal to t, f dash x dx equal to dt. So, this is f of x is t raised to power n and f dash x, this is dt. So, this is t raised to power n plus 1, the first formula, over n plus 1 plus c. And now replace this t by f of x whole raised to power n plus 1 divided by n plus 1 plus constant c. This is the right hand side. Of course, in this case, this is the right hand side in the first case. So, you will find in solving these questions on integration, we shall be making use of both these formulas quite often. Next formulas are, this is integral of tan of x d of x is log of secant x plus c, or this is minus log of cos x plus c. Now, in this case, we take the left hand side, tan of x d of x multiplied by secant of x and divide by secant of x d of x. The secant x will get cancelled. Now, derivative of secant x is tan x secant of x. We observe, we apply the formula f dash x upon f of x d of x, integral of this as log of f of x plus c. This is because derivative of the denominator secant of x is tan of x into secant of x. So, this is log of secant of x plus c. This is the first form. For getting the second form, again either we can get from here as log of cos x to minus 1 plus c, and use the basic formula for logarithms as log of m raised to power n as n log of m. So, take this minus 1 outside, minus log of cos of x plus c. This is your second form. Then we have the second result in this case is integral of cot of x d of x is log of sin of x plus c. If you take the left hand side, this is integral of cos x upon sin of x d of x. Now, derivative of sin x is cos x. Apply the same formula f dash x upon f of x d of x as log of f of x. Of course, this is log of sin of x plus constant c. Well, moving a step further, we have another two important results as integral of secant of x d of x. This is equal to log of secant x plus tan of x plus constant c. And integral of cosec of x d of x equal to log of cosec x minus cot of x plus c. We shall derive another result here. Integral secant x d of x. Well, integral of secant x multiplied by secant x plus tan of x and divided by secant of x plus tan of x. And d of x. Let secant of x plus tan of x equal to t. So, derivative of secant x is secant of x tan of x plus secant square x d of x to d of t, or take out secant of x common. So, tan x plus secant of x d of x d of t. So, in the numerator we have secant x into secant x plus tan x, which is dt upon t. So, this is formula is log of t plus c. Otherwise, when you substituted secant x plus tan x equal to t, another way orally you could say that derivative of secant x is in the numerator, secant square x, secant x tan x, and derivative of tan x is secant x into secant x, secant square x. We use that here. So, you could use the formula or this f dash x over f of x d of x integral of this to log of f of x plus c, or you could do it in this way. Now, replace t by log of secant of x plus tan of x plus c. Now, this is the first form of this. If you want to go further one step more, so this will be change log of secant x is 1 by cos x plus sin x upon cos of x plus c, or this is equal to log of 1 plus sin x over cos of x. Making use of the formula in trigonometry of submultiple angles, we can write as 1 plus cos x as log of cos x by 2 plus sin of x by 2 and square of this. And formula for cos x is cos square x by 2 minus sin square x by 2 plus constant c. Well, these are very popular formulas 1 plus sin x equal to cos x by 2 plus sin x by 2. Otherwise, if you want to confirm it, you can square it and you get the result. Now, further we can write down this is log of cos x by 2 plus sin of x by 2, square of this divided by difference of two squares, cos of x by 2 minus sin of x by 2 and cos of x by 2 plus sin of x by 2. This cos x by 2 with plus sin gets cancelled square of this, and you are left with log of cos x by 2 plus sin of x by 2 upon cos x by 2 minus sin of x by 2 plus c, or log of, we take out cos of x by 2 common. So, this will be 1 plus tan of x by 2. Here also cos of x by 2 common, 1 minus tan of x by 2 plus c. This gets cancelled. We have log of tan of pi by 4 plus x by 2, 4 plus x by 2 plus c. This is the second form, which you can put now here, log of tan of pi by 4 plus x by 2. Sometimes this second form of this formula, this is the first form and this is the second form, is required in integration. Then we have the second result, log of cosec x minus cot, the integral of cosec x. So, well, this is integral of cosec x d of x, or this is integral of cosec x into cosec of x minus cot of x d of x, and divide by cosec x minus cot of x. So, this step you shall have to remember, and hint for this is you multiply cosec x minus cot x in the numerator and denominator. This factor will cancel out and you are left with cosec x dx. Use the formula this here, that f dash x upon f of x d of x log of f of x. So, this will be log of cosec x minus cot x plus c. This is the first form of this. To obtain the second form, we change this into sin and cos, 1 minus cos x upon sin of x. Now, look here, cosec x is 1 by sin x and cot x is cos x over sin x. Take the LCM as sin x, numerator you will get as 1 minus cos x for this plus c. Formula for this is log of 1 minus cos x is 2 sin square x by 2 and sin x is 2 sin of x by 2 cos of x by 2 plus c. 2 gets cancelled with this, square gets cancelled with this, you are left with log of tan of x by 2 plus c, and this is the second form which we will put here. This is log of tan of x by 2 plus constant c. This is the second form. So, this is the first form here. Both these forms are frequently used in integration. Well, what is more important is knowledge of trigonometric formulas is a must. If you happen to see my last videos, third and fourth, I have drawn all these trigonometric formulas of trigonometric functions of multiples of some angle and some multiples of angle.